Solve the square root of 3 minus x equals 2 times the square root of x plus 2. I'm going to rewrite this equation over here just to have a little bit more room to work with it. You'll notice that this is a little bit more complicated than the ones we've seen before, because here we have two radicals in the equation. But with an equation like this, we can still square both sides to get rid of the radicals. And that's what we're going to do from the beginning. We are going to square both sides. The left-hand side just leaves us with 3 minus x, because squaring a square root gets rid of the radical. So we just have 3 minus x on the left. On the right, we are squaring a product, and so we actually have to square each of the factors. Now we have to be very careful here and do these one at a time. If we take 2 and square it, we know that 2 squared is just 4. So we're actually going to square the 2 in that situation. In the other case, when we're taking the square root of x plus 2 and squaring it, we know that squaring a square root gets rid of the radical. So in this case, this factor is going to be x plus 2. Here, when we square the second factor, squaring it gets rid of the radical. So we're just left with x plus 2. But because this 2 was not inside a radical, when we square it, there's not a radical to go away, so we actually have to square the 2, and the 2 squared becomes 4. So in a situation like this, anything that's inside a radical, the radical just vanishes when we square it, but anything that's outside of a radical actually needs to get squared. That's why the 2, when it was squared, became a 4. Now that we've gotten rid of the radicals, we can solve this like any other linear equation. We need to distribute the 4 on the right-hand side. When we do that, we end up with 4x plus 8. And now we need to isolate x. We have x's on both sides of the equation, so we need to eliminate one. I'm going to eliminate the x on the left by adding x to both sides. This leaves us with 3 on the left and 5x plus 8 on the right. To get the x alone, we subtract 8 from both sides, giving us negative 5 equals 5x. And to get x alone, we divide both sides by 5, and this gives us negative 1 equals x. Now we do have to be careful because we squared both sides in this problem. So whenever we do that, there's the possibility of extraneous solutions, and so we need to check any solutions that we end up with. If we substitute negative 1 in for x, we have 3 minus negative 1 under the first radical, and we're hoping that that equals 2 times the square root of negative 1 plus 2. On the left, 3 minus negative 1 is the same as 3 plus 1, which is 4. So we've got the square root of 4 on the left. On the right, we've got 2 times the square root of negative 1 plus 2 is just 1. So we have the square root of 1 on the right. Now on the left, the square root of 4 is 2. And on the right, the square root of 1 is 1. So we have 2 equals 2 times 1. And we know that that's true. So x equals negative 1 is an actual solution. And it's the only one, so our final answer is x equals negative 1.